Hello, Sawadee. My name is Angkurn Tanasittikun. I'm from Montfort College. Today, I'll be presenting my solution to the IYPT problem, ping pong ball rocket. Let's have a look at the experiment overview. Here's the experiment setup. This is the data collection method. We have a phone recording in slow motion. We can view the footage from the phone recording in slow motion to measure the height of the ping pong ball. Each measurement is repeated 3 times and the error is calculated using standard deviation. This is the experimental assumptions and conditions. This is the experimental parameters. This is the experimental result for swirling the water. As you can see, there is a significant height difference between swirling the water before dropping it and not swirling the water before dropping it. There's a great difference between the two. Here's the experimental result for different amounts of water in the container, and right here we have the wide angle view of the experiment for comparison. As you can see, the optimal amount of water for the maximum height is around 60% of the maximum capacity of the container. Here's the experimental result for the initial drop height. And here's the experimental result for different cups diameter. One possible explanation for this is that narrower container can cause the ball to bounce around more, losing kinetic energy in the process. Next up, we have theoretical analysis and calculations. So to approach the problem, we first need to know that the collision between the floor and the container is inelastic. The energy of the system will dissipate out. So using the model like the Galilean cannon might not be so accurate. So we can approach this problem by investigating the water hammer phenomenon, which is caused by the collision of the container with the floor, creating a pressure wave traveling upward. We can calculate the water hammer pressure by using the Joukowsky equation. It's like closing a valve overflowing water because we are disrupting the liquid's momentum. Here is the Joukowsky equation. And next up, we need to calculate the change in velocity. So to calculate the change in velocity, we need to know the velocity before the impact and after the impact. So to calculate the velocity before the impact, we can use the conservation of energy. And velocity after the impact, as you can see, the cup containing the water barely bounced up. So we can assume that the velocity after the impact is 0. So here is the delta V right here. And now we can calculate the work done by the pressure by integrating F dy right here. We are also assuming that the pressure exerting on the ping pong ball is constant, so we can solve for this integral. So we will get the equation to determine the final height of the ping pong ball. Next up, we also observe that there is a formation of water jet after the collision. This water jet is caused by the water hammer. As seen from the video, our cumulative jet has a non-uniform geometry, so we cannot find the exact radius of the jet, and the calculation for that is very complex. So let's validate our experimental results. So here is the relation between the submerged depth and the final height. So we can determine the maximum final height of the ping pong ball is when the ping pong ball is fully submerged underwater, right here. A Mayo vortex is created as a result of swirling the water, making the ping pong ball more submerged and will increase the ping pong ball final height. And this is the relation between the initial drop height and the final height. As you can see from the equation, the higher the initial drop height, the higher the ping pong ball will get launched. To maximize the final height, another parameter we need to consider is the temperature. The temperature of the water will affect the density and the wave speed of the water. The optimal temperature for the maximum height is around 60 to 70 degrees Celsius. In conclusion, we identified several important parameters, but unfortunately we cannot accurately determine the maximum height of the ping pong ball because of limitations. We did determine the condition to maximize the final height of the ping pong ball.